Hello, and welcome to our presentation to the 2022 Hypertext Conference entitled Hypertext's Meta-History. Both myself and my co-author David Millard are members of the Web and Internet Science Group at Southampton University in the UK. I'll be presenting some of the findings from our paper before exploring issues encountered in making the underlying dataset. The DOI URL for the dataset is shown here and on the final screen. Part of the aim of this work is to encourage others to make better use of the conference's metadata. Our research covers published information from 33 hypertext conferences held between 1987 and 2021. Data for all except one conference was recovered from the ACM's Digital Library, DLACM. Unlike its later editions, the very first European Conference on Hypertext in 1990 was never formally adopted by the ACM. Our analysis includes ECHT 90 as it contains several important hypertext papers and it plugs an early gap in the Hypertext Conference's history. Data from this conference was sourced from printed proceedings. The detailed counts of conference contents are in the paper, so I'll proceed to look at some of our findings in more detail. In this chart, we show the persistence of author participation in the Hypertext Conference up to 2020. The y-axis shows the overall count of unique authors for that conference. The top grey layer indicates authors publishing once, but never again. The yellow layer are authors new to the conference, but who will publish again. Blue shows authors who publish at least one more time after their first year during the overall reported period. Over time, any author publishing for a second time would subsequently migrate from the grey to the blue bar. Fall-off of the yellow-blue count since 2014 can indicate either a fall in author participation or simply show that the data is still inside the average participatory life of any discrete author. The conference's annual SIGWeb Town Hall meeting often glumly debates underrepresentation of women authors. This chart attempts to replace conjecture with data. Lowest overall involvement was 24% in ECHT 90. Encouragingly, the overall trend is upwards with a lifetime average of 41%. By comparison, whilst female first authors average only 22%, again there appears to be a healthy upward trend. Not tabulated are keynotes and panels, where conference organisers have made a strong effort to have a balance in the gender of presenters. Data on individual authors assessed gender is deliberately excluded from the current public dataset, but we are happy to discuss it with bona fide researchers. Now to author keywords, which appear to be of less use than imagined. Over 3/4 of keywords are nonce terms, occurring once across the corpus. Less than 1% make up aggregated themes, as shown here, that occur in 20 or more items, though some obvious terms do show up. In fairness, predicting new trends or key terminology is difficult in young emerging fields of study. But generally, the poor selection of useful terms may indicate authors are choosing keywords descriptively and without due thought as to how these are employed in search. A suggestion is to find a way for the conference to do post hoc keywording of items so as to improve the quality of search results. I now want to turn to the dataset underlying these findings and the issues arising in its creation. Most surprising was a general theme of observations along the lines of why bother? There seemed to be a presumption that this work either pre-existed or was too trivial to undertake. Before addressing those aspects, first let us consider what having an abstracted dataset allows us to do. In the mind's eye, visualization can seem a trivial task. But even with a clean set of underlying data, there are many considerations of scope and granularity needed in order to get a meaningful rather than a merely pleasing display. Shown here are a pair of experimental visualizations using earlier versions of the current dataset, which is provided as a pair of discrete node and edge plaintext tables. Both demos use the same data. I'll now switch to a web browser to show these. The first proof of concept demo explores use of Gephi and Sigma.js plugin to create a web page. Conference items are plotted around the circle with a discrete color per year. Each circle node is a paper, its size reflecting its inbound citation count. Hovering over an item shows the title, and the graph then shows only that item's in and outbound links. Clicking an item opens a sidebar with more data about that paper. Clicking on its linked list allows traversal of the graph. It is also possible to use keyword search to find papers. The second demo combines two switchable views. The first shows a left-to-right timeline of papers, the conference year below, a stack of its papers, and with a count of the papers above. Hovering over an item shows that paper's title, and also highlights any cited and citing items in blue. Clicking an item loads information about the paper into the lower part of the screen. A search box allows keyword search, with matching items being highlighted in yellow. Press the Tab key to toggle the alternate display. Here, all items are listed in a top-to-bottom scrolling list. The selected list items citations are to the left, and citing papers to the right. Both these lists are clickable, allowing navigation of the graph. Press the Tab to toggle views again. Returning now to misconceptions about the dataset, I present 3 of these, in no particular order as they're interrelated. These suggestions, all made to me during the research, came with no ill intent. Nevertheless, I think it highlights mispresumptions around the collection and analysis of conference information. Firstly, why not just use pre-existing citation data? This suggests naive assumptions about the quality of primary sources. Excellent as resources like DBLP are, they are only as accurate as their creation from a primary source. Thus, any errors in DLACM are found in these secondary sources. Indeed, use of such secondary sources for data can lead to a false belief that the data is complete or clean. However, when resolving errors and omissions in the primary source, some other secondary sources, as shown below, were found to be useful for cross-reference. Next, why not use an API? Again, this suggests lack of knowledge of the domain data. The DLACM has no API and expressly forbids and actively polices the use of screen scraping, nor does it have any obvious conduit for requesting research access to the data. There is also no organised channel for researchers to report errors or omissions for fixing. My research found some 700 conference items unrecorded, equivalent to half the available corpus. In fairness, this is due in part to the limited scope of proceedings content. Still, information such as keynotes by significant hypertext figures are unrecorded. Indeed, some unrecorded keynotes are nonetheless cited in papers, which seems a bibliographic failure. APIs aren't a problem though. They do aid rapid acquisition of data, yet can also obfuscate possible errors or inconsistencies in the data. Lastly, why use an app when you can write new code? This mispresumes the data's cleanliness and coherence. Regardless, the assumptions being encoded can result in premature formalization with inevitable replanning and recoding. I see no zero-sum choice here of code versus app. Certainly, there was no harm in using, as we did, a pre-existing tool. In fact, Tinderbox proved to be excellent both in supporting exploration of what source data was pertinent to the dataset and in examining the consistency of the data. Tinderbox's support for incremental formalization was a significant boost to the speed of progress. Whilst bespoke code might have acquired data more quickly, it is not clear it would improve the pace of the necessary cleaning and sorting. The general theme emerging here is that promoting the writing of new code over taking time to understand the data is a false economy in tasks like these. So what then do we take away from this? What could or should be done? First, we would suggest, is to investigate the degree to which our current data collection reflects a status quo derived from a print age in which we no longer live. We should consider what information is useful to and effective for today's researchers when using the conference's output. The conference depends on much freely given community effort, but the clarity of the brief given to conference organisers with regard to data collection is uncertain. Is there a clear and actively maintained manifest of the data to be recorded? How and for what purpose? Be it for use in proceedings or in other offerings. Data should be planned output and not simply the exhaust from the process. Visualizing the conference's work can make the information more accessible to a wider audience. In turn, this suggests we consider the collection and recording of data with a mind to how it can be used for visualization without complex reworking. If not all data about the conference can or should formally belong in the DLACM, where might it be put? For instance, could the SIGs host some of it? There is also little point in generating tasks that can't be serviced, so might we not engage more of our community at all levels in stewardship of this data? Tasks undertaken by junior researchers offer an early opportunity to engage with and build links within the Hypertext community. These things are possible, but will we embrace the opportunity? What will next year's proceedings contain? Thank you for listening, and we would now be happy to take any questions you may have. Thank you.